Assalamu alaikum. Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid, and today we're going to talk about matrices and the most fundamental operation, which is the addition. Now, here is an example of matrix A, matrix B, which gets added together to become matrix C. Here I've explicitly shown in different colors. For instance, row green gets added up with row green to become the answer, which is also shown in green color. The same goes for red, the same goes for blue. So element 3 gets added with element 2 to become element 5. Now, one of the fundamental requirements of addition here is that the dimensions of A and the dimensions of B should be exactly the same, and then you'll get C. So we see the dimensions of A, B and C to be the same. So in other words, the rows of A should be the same as rows of B, and the columns of A should be the same as the columns of B. So in other words, prior to actually doing the addition process, you should check if their dimensions are the same, right? So this is an example of exception handling being applied here as well. For those of you who need to learn how to handle exceptions, I would recommend go back to the last lecture, which is lecture 17 on exception handling. So how do you initialize a matrix? Well, you need R1 and C1, which is the rows of a matrix and the columns of a matrix. We are doing this using a pointer, right? So you just simply say new integer R1 times C1. So this actually allocates a space in the memory equal to the number of elements R1 times C1, where each element is of 4 bytes because this is an integer. Then you initialize an array and you can print it. Now, if you want to see how this works, I would recommend you go back to lecture number 16. Over there I've actually dedicated an entire lecture on explaining how this works. And you want to print the array, this is how I've actually developed a function and I've explained how it works in lecture number 14. So I would recommend to go back to 16 and 14 if you want to see how this works. So let's say the person actually initializes something like this. To initialize the second matrix, you literally copy paste the same code here, and you do the same with matrix number 2. The difference is, however, is that you're using R2 and C2, right? And for matrix 1 you're using R1 and C1. Similarly, using P1 and P2. So this is P2, where you allocate a space in the memory which is equal to the number of R2 times C2 number of elements, and then you initialize and print. Now, as far as the addition is concerned, because you have a new matrix as an output, which is matrix C, I would strongly recommend using an element. So the new matrix has its own number of columns and rows, and you need a pointer to point to the first element of the new matrix C. Now, for the addition function, remember you need to check for exceptions prior to the actual calculation. So this try, throw and catch blocks are present within the addition function. So here you're going to check if R1 is equal to R2. In other words, the number of rows are the same of A and B, and you have to check if the number of columns are the same. If they are, then you can do the addition. If they're not, you can just throw anything, really just anything. And then you can use these 3 dots. So when you're really not sure what to throw, just within the catch arguments, just put 3 dots and you can just play around with it whatever way you want. And you can just say addition is not possible. Normally at this stage you should also tell why is it not possible. I think a good statement would be the dimensions don't match up. And then because you just the answer is an element matrix, so it's useful to just put it to default values. Okay, now for the addition itself, right, you're just going to use these new variables A, B and C, where A will store the element of matrix 1, B will store the element of matrix 2. You're just going to add it and put it where the contents of the matrix lies, right, in this new address. So if this is hard to understand, this I've taken directly from the initialize array function. Now I've discussed that in lecture number 16, so you can go back there. So I'm just using the same. P1 corresponds to matrix 1, P2 corresponds to matrix 2, and matrix dot P is actually our guy C, the example that I gave you at the very beginning. In other words, matrix 3. So M3 is actually M1 plus M2. So here is an example of the complete code, right? So this is how I've initialized. I've asked the user to tell me what's matrix 1 is, so the number of rows and columns, and here I've allocated a space in the memory, I've initialized it, and I've printed it. I do the same for matrix 2, and then I declare matrix as an element because it's a new matrix, and then I'm just assigning it to the addition of matrix 6, where I'm really passing, you know, the entire two matrices. If I look at the addition function, right, this is my addition function, this is my catch block. In other words, if the rows and columns are not the same, right, if the rows of A and B, and you have to have two ampersand signs for that, and the columns of A and B are not the same, you should throw like whatever, and just these three dots will kind of like handle it. And then you can say, well, addition is not possible because matrix 1 dimensions are not equal to matrix 2, and then because it was a structure element, you should put in some default values like 0, 0 and null. And if it actually is equal, in that case you initialize C1, you initialize the rows and columns, you allocate a space in the memory, and you just do the calculation. Now prior to ending the function, it's worthwhile to mention that you should always delete pointers. If you initialize them, you should always delete them. You shouldn't leave dangling pointers. Dangling pointers are the pointers where the function ends, but they kind of like stick on to the memory. So that's just memory not being available for anything else. So you should always delete pointers. You shouldn't allow dangling pointers. So if I was to run this function, right, here I'm running this function, lecture 18. Okay, it asks for the number of rows here. I can say 2 rows and 2 columns, and then because I don't want to do the multiplication the first time, so I'm just going to say 1 row and 2 columns. So I'm just quickly putting in values. So that's my first matrix, and then I'm just going to quickly do something. Okay, this is my second matrix. Because right, addition is not possible because their dimensions are not the same, they say addition not possible, right? But let me try it differently this time I want it to work. So I'm gonna have 2 rows and 2 columns, and quickly I just want to, you know, start it. So it's 1 2 3 4, and the second matrix I'm going to make it simpler so the calculation is easier. So I'm going to initialize it to all 1. So that's my second. Obviously adding 1 2 3 4 with 1 1 1 1 gets us 2 3 4 5, right? So thank you very much for watching. Subscribe and hit the bell icon to get notified for newer videos. Thank you very much. Bye bye.